Let's graph the compound inequality. Y is less than 2x minus 1 and x minus y is less than 3. We have two inequalities that we're working with. We're going to start with the left-hand side, and we're going to generate a boundary line for our inequality. And it's going to be a dashed boundary line because of the inequality symbol not containing the equal symbol. So we're going to graph this as y equals 2x minus 1. We're going to generate a couple of ordered pairs so that we can graph this on our graph. So our first point, we're going to allow x to be 2. We'll replace that into our equation. We'll have y is equal to 2 times 2 minus 1. Y is equal to 4 minus 1. We'll have y is equal to 3. So the first ordered pair that we have is 2, 3. Now we're going to let x be 0. We'll substitute that into our original equation. Y is equal to 2 times 0 minus 1. And we'll have y is equal to negative 1. So our second point is 0, negative 1. These are to graph our boundary lines. We now need to move to the next inequality. We need to do the same process. We're going to graph this or set this up as x minus y is equal to 3. We're going to allow x to be 0. We'll substitute in. We'll have negative y is equal to 3. We'll solve for y by dividing by negative 1. Y is negative 3. So our first ordered pair is 0, negative 3. We're also going to let y equal 0. So we'll have x equals 3. Be careful how you write this ordered pair. X has to come first, so this ordered pair is 3, 0. We now have 2 points, one for each of our boundary lines, that we're going to graph on the same graph. We have y is less than 2x minus 1 is one of our original inequalities, and x minus y is less than 3. We have our points 2, 3, and 0, negative 1. And over here we have 0, negative 3, 3, 0. So we're going to have to graph both of these on our graph simultaneously. Both are dashed boundary lines. So let's put our points on. We're going to call this line number 1. Two, and then up 3. We'll place our first point, and 0, negative 1. We're going to connect those with a dashed line. I'm going to label that line 1. We also now need to put the boundary line for our second inequality on as well. First, we're going to do a test point. The test point that we're going to choose is 0, 0 for line number 1. If this has our initial inequality remain true, then we get to shade that side of our graph. 0, 0 is right here. We'll place that into our original inequality. We'll have 0 is less than 2 times 0 minus 1. Is 0 less than negative 1? And that's false. 0 is not less than negative 1. So 0, 0 did not check as a test point for this line number 1, so we are going to shade the opposite side. Now let's do the second inequality. Let's place our intercepts at 0, negative 3. We'll label that. And at 3, 0. Again, we also need to connect these with a dashed boundary line. And we're going to label that line 2. We also need to do a test point. So let's test 0, 0 in the original inequality. So it'd be 0 minus 0, is that less than 3? 0 less than 3? That is a true statement. So anything above line 2 on the same side as 0, 0 gets to be shaded. So we're going to try and shade this a little sneakily. We're going to go the opposite direction so we can see what we result with. Notice we have an area here in the center that contains both our diagonal lines and our horizontal lines. So this, in fact, is the solution to the compound inequality, to both at the same time. And you can hatch that a little further to see it a little more visually, that this strip in the center is the solution to both of our inequalities simultaneously.